Good morning, Miss. Good morning, everyone. So my topic is equilibrium equations of composite bodies. And I have here a problem found in our book, and it states here that the figure shows a wire cutter. Determine the cutting force in the wire at A when the 75 Newton forces are applied to the hand grips. In the horizontal components of pin forces at A and B are zero due to symmetry. And here is our figure, and its dimensions is in millimeter. So basing on the hint, our Bx and Bx will be equal to 0. Then next, I draw the FPD of the whole figure with 5 unknowns, and I have the assumed directions. So at A, I have an assumed direction facing upward, BY would be downward, CY upward, CX would be to the left, DY is upward, and the E is already given with with a 75 Newton force. And at the FPD of member ABC and FPD of member CDE at point C, I have different assumed directions since we have to apply Newton's third law. So after isolating the members of the body, the whole I can see any unknown external reactions from the whole figure, and FPD of member ABC are all unknown. So I started to compute using the FPD of member CDE. So in here, I used the summation of moment at P would be equal to 0 in a counterclockwise direction. So I have here Cy with its multiplied by its moment arm, which is 24 millimeter, subtracted by the 75 Newton force with its moment arm 72 millimeters equal to 0. Then I equate the 75 Newton force, and to get Cy, I divided both sides with the 24 millimeter. No, cancel ang meter sa 5,400 Newton, which is the product from 75 multiplied by the 72 millimeter. So I have here Cy would be equal to the 225 Newton. So I already have the value for Cy and also have the value at E. So I can now get the value for dy using the summation of forces at y is equal to 0. So I have here negative Cy plus dy minus the 75 Newton. So Cy is negative 225. And then to get dy, I transpose the given values. So 225, ma-change ila signs, kaya can transpose ko sila sa piyak. So 225 Newton plus 75 Newton, which that gives me 300 Newton. So I have now the value for Cy and dy, and I can compute for equation with Cx since ga intersect siya sa tanan na component, intersect sa D kag sa E. And so for FBD of member ABC, I have here the value for Cy already, and my goal is to get the value, the force applied at A. So summation of moment at P is equal to 0 in a counterclockwise direction to get FA. So negative FA, because it is in the counterclockwise direction, multiplied by its moment arm, which is 27 millimeter, plus Cy, and its moment arm is 80 millimeter. So I transpose, Cy has already the value, and that would be 225. Then I transpose FA, and it will change signs. Then 225 multiplied by 80 is equal to 18,000 Newton millimeter. And then I divided both sides with the 27 millimeter. Makancel ang 27 millimeter sa FA, kag ang millimeter naman sa piyak. And now, dividing 18,000 Newton with 27, I got 666.67 Newton. And now that I got the value for FA, I also had the value for Cy. To get the value for By, I use the summation of forces at y is equal to 0. So Fa minus By plus Cy is equal to 0. And then I put on its values. And now, since I am looking for By, again transpose ko ang By, then ma-change ang iya sign. So By is equal to 666.67 Newton plus 225 Newton. So By would be equal to 891.67 Newton. So Cx here, since wala, since intersect naman siya liwat sa tanan component, summation of forces at x is equal to 0, so Cx is equal to 0 Newton. And that's how I come up with the solution. Thank you.